Today we move on away from just the law of sines into the law of cosines. We're going to find some cases where the law of sines won't get us there. So, the 4 cases possible, we apply the law of sines. And now we're going to do the law of cosines. Please notice there are 3 equations associated with the law of cosines. You remember back here with law of sines, well, actually I guess we could say there are 3, because it's not 3 equations though, it's 3 proportions, right? The sine of an angle is equal to the sine of any other angle, provided they're being divided by their opposite side. So there's the law of sines. And in this lesson today, we're going to be working with the law of cosines. We'll work later on finding the area of a space and doing some word problems. Ooh, that'll be good. Okay, we've done this, right? Law of sines for angle, angle, side, or angle, side, angle. So anytime you know 2 angles and 1 side, you certainly can use the law of sines. The thing is that even if you don't have the proper pair, as long as you've got 2 angles, you can always figure out what that 3rd angle is, right? These 2 are a little trickier. The only combinations in which we cannot, or the only combination where we cannot determine congruence is this one. This one, of course, we've spent a lot of time looking at. This is the ambiguous, where we can either have no solution at all, 1 triangle that works, or sometimes 2. In the case of 2, we will always have 1 acute angle and 1 that's done with an obtuse angle. And we know how to find, we always start with this one and then figure out what the obtuse is. So let's look at these 2 cases here, SAS and side, side, side. Let's think about why we can't use the law of sines here. Is there any way I can get a pair? How can I ever establish a ratio? And this one, give it up. There's no way. We can't get the ratio that we need. So, picking up from our geometry lessons of a couple years ago, we've got the angle, side. Here we have an angle that's given, another angle that's given, and then a side which is not between them. We also have angle, included side, angle. Either one of these is a perfect candidate for law of sines. We've worked a lot with having 2 sides and an angle which is not included. Now we're going to look at when we've got side, angle, side, and side, side, side. So here's our side, an included angle. So both of these sides are adjacent to the angle. Then we have the situation where we've got all 3 sides without a single angle. The ambiguous case, we can use either the law of sines or the law of cosines. Let me tell you right now, the law of sines, at least for my money, the law of sines is the easier one to deal with. When you look at the law of cosines, what's going to strike you is that it's not a ratio. What it actually looks like is the Pythagorean theorem. It is often referred to as the generalized Pythagorean theorem. Why? Well, that means we can apply it to oblique triangles. The Pythagorean theorem, the pure Pythagorean theorem, only allows you to apply it to a right triangle. So we could generalize it to any triangle, and we would call that the law of cosines. Let me show it to you. The law of cosines comes in three flavors. Well, when you look at it, basically, it is every single one of these is just the same as the one above. It's just a change in orientation. Let's just look down through one of them. C squared, so that would be this length here. So we just pick a side. Suppose we pick C. Then we're going to say we're going to square the other two sides, a squared plus b squared, and then we're going to subtract. We're going to subtract a product, and here's where our trig comes in. We're going to take the cosine of the angle opposite the side that we squared first, and we're going to multiply that times the length of A, the length of B, multiply it times 2. That's our product to subtract. In the case of b squared, all right, here's b. We square it. That will equal this squared, and minus these two times each other, times 2 times the cosine of the opposite angle. You can see that each one of these is identical to the one above. It's just a matter of orientation. Solve this triangle if possible. That's going to come up a lot now, because we may actually have numbers sometimes that are not solvable. Approximate values to the nearest tenth. So we know what we're going to give for an answer. Now we're going to fill out our chart just like we always have. We do not know what alpha is. Beta is unknown, but gamma is 20 degrees. We have A is 11. We have B is 5. So, I want to find out what C is, right? So which one am I going to choose? I'm going to choose this one. Now how do I know that right off? Because I have A and B, and I have gamma. So I can use this one. On all the others, I don't have what's necessary. So C squared is going to equal 11 squared, or 121, plus 25, minus, now 2 times A times B, that'd be 55 times 2, or 110. Did I do my arithmetic right? And then the cosine of 20 degrees. So that one we're not doing in our head, are we? Turn this on. Make sure we're in the right mode, which we are not. We want degree mode. Now we're going to say cosine of gamma, which is 20. Cosine of 20, it knows we're talking degrees, and that is, let me write it down, 0.9397. Always go to 4 decimal places. 0.9397. Okay. Now let's go ahead and do the rest of the calculations right here on our calculator. So times 110, and I'm going to say times -1, because I want that. Oh, it didn't like it. Of course it didn't. Okay. Quit. So I'll say times, I used the wrong negative, didn't I? -1. Alright, so all I wanted to do was get the sign changed. Now I could add these two together in my head, right? This would be 146. Bring this back up. So plus 146, and I think that c squared is 42.634. C squared equals 42.634. Now, one of the things you would, I bet will happen sooner or later, is you'll get this far and you'll think of that as being c. No, that's c squared. And I can tell, at least with this particular problem, that c squared couldn't possibly be the answer, because if we add up 11 and 5, we get 16. This has to be less than the other two sides added together. Otherwise, you can't build a triangle with it. So we want to take the square root of this. How do I like to do it? I like to say raised to the power of 1/2. Okay, remember the power of 1, the root is 2. I'm taking the square root by doing this. So 6.5, well, that seems reasonable. 6.5, I suppose I should say 6.5. No, we said to the nearest tenth. Let me follow my own rules. 6.5 works just great. Now I've got some other calculations I need to do. I haven't solved the triangle. I've got the 3 sides. Now I can go to the law of sines. Or, no, it's just the easiest way now is to go to the law of sines, I think. Or, let's see, we could say the sine of 20 degrees over the length 6.5. There's our ratio for the law of sines. Okay, so I'm going to say sine 20 divided by 6.5. This is the ratio for law of sines, 0.05262. 0.05262, and I can use that now to find alpha and to find beta. So let's go ahead and do it. The sine of alpha, oh, I don't have to use the A. I can put the number right in there. Wouldn't that make more sense? Yep. So opposite side is 11. And we know that in law of sines, this ratio stays the same. So to find what my sine of alpha is, I'm just going to multiply this times 11. Oh, not, excuse me, times 11. So now I've got the sine of alpha equals 0.5788. So I have the ratio. I want to know what the angle is. This is when I go to arc sine of 0.5788. So alpha is 35 point, we're rounding to the nearest tenth, 35.4 degrees. 35.4 degrees. If I know alpha and gamma, I can figure beta without having to go to trigonometry. And why would I bother with trig if I don't have to? So 180 minus 20 minus 35.4 gives me beta. 124.6 degrees. 124.6 degrees. All right. Well, with that example, let's do it again. Now this time we have all the sides. Let's mark in the information that we have been given. We have A is equal to 9, B is equal to 7, and C is equal to 5. So in this case, we actually have all the sides. So what is going to guide us on which one we use? I guess it doesn't make too much difference. The thing we're actually going to be solving for is the angle. So the first thing we'll find will be the cosine. We'll have the ratio, the cosine ratio, then we can figure out what the angle is itself. So let's do this one. We could use any one of them. They, I think, equally indicated. Doesn't matter. So a square is 81 equals b square, which is 49, plus 25 minus b times c is 35, twice that is 70, cosine alpha. So as we start here, we're going to find out what cosine alpha is, and then we're going to find out what alpha itself is. So it's a two-step process now. Let's go back to it. So if I add 70, cosine alpha to both sides, I'll have 70 cosine alpha equals, now at the same time I'm going to subtract 81 from both sides. So I'm going to subtract 81 from both sides. And what do I have right here? If I add these two together, it better be greater than 81. So what is it? It isn't greater than 81. Well, this is a weird thing. This is not what I expected. Did I make a mistake? Let's make sure. A square is 9. B square is 49. And C square is 25. I add these together, it's 74. Then I subtracted 81 from both sides, and I added, well, let's keep going. So we're going to divide both sides by 70. And I end up with the cosine of alpha. Let's get it over here. Turn it on. Let me check my mode. I'm good. Okay, the cosine of, oh, that's not going to do me good. Back up, clear. I need to figure out what the ratio is first. And then I'm going to be using arc cosine. It's 74 minus 81, so I'm going to have a negative number here. Doesn't seem right. So a negative 7 divided by 70. So I'm going to have minus 1/10. You write it down. Minus. Alright, so alpha equals the arc cosine, which is always written this way, of this ratio. Let's see what it is. Cosine alpha. Oh, you know what it might be? You know what it might be? It may be that it's an obtuse angle because cosine is negative over here. I shouldn't have been so worried about it, perhaps. Let's see if it works. Arc cosine of Now I'm going to use the correct negative. Congratulate me on that. Yeah, so it's an angle of 95.7 degrees. So alpha is 95.7. 95.7 degrees. So it was an obtuse angle, of course. That makes sense. Now, because I'm not a big fan of the law of cosines, I'm going to go to the law of sines, which tells me that the sine of 95.7. Oh, I hate that. What I need to do with my pen is to do point and then wait and then put in my 7. That will always work. Divided by 9. So let's find out what that ratio is. That's interesting. That ratio is going to be a negative, isn't it? All right, let's go. Sine of 95.7. No. In this quadrant, sine is positive. This is all working out beautifully. Okay, so we got the sine of that angle, and we're going to divide it by 9. And we get a ratio of 0.11056. 0.11056. This is for our law of sines. This will allow us now to find beta. So we can say the sine of beta, which we do not know, over its opposite side, which we do know, is equal to the law of sines ratio. So in just a moment here, we'll know what the sine of beta is. All we have to do is multiply our law of sines ratio times 7. Times 7. So the sine of beta is equal to 0.7739. 0.77. See how nicely I paused there? So beta is equal to the arc sine of this ratio. Let's see what that will be. Arc sine of 0.7739 50.7 degrees. 50.7 degrees. If I add 95.7 to that, and then find its difference with 180, I know that gamma is 33.6. Remember, we're approximating to the nearest tenth. 33.6 degrees. Does that look good? And it's a match to what I had figured out sometime before. All right, here are some examples right out of your book. Let's see how many I've got us to go through here. Let's see, we've got a couple here, and then, that's interesting, 17, 18, and then we renumber. The numbers are so messed up in this part of his workbook. It's not a big deal, though. Doesn't bother us, right? We go with the flow. A drawing is not necessary when we're doing SAS. as long as I would recommend you always put together your little table. Start with the given angle. So if you are given SAS, if you are given alpha, then you're going to use this formula here. Find a squared, then find a. We can do that. Now that you have both, you switch to the law of sines. Why do we do that? It's easier. Of course, we will want to do it in the easiest possible way. Find the smaller angle by using the shorter of the given sides. Well, that's a good hint. And then, of course, we have no problem finding our third angle. So let's start out with this. We're going to want to use this for number 17, right? Because we have alpha. So what is the cosine of 68 degrees? We'll just get that before I even get started. Cosine, we'll turn it on. Cosine of 68. Find out what that is. All right, there it is. And what are we going to do with that? We're going to multiply it times b, c, and -2. So times b, which is 8, times c, which is 5, times a -2. All right, so that's this product that we're subtracting. And there it is, a negative number, because I put in a -2. Now I'm going to add to that b squared and c squared. B squared, I'll add 64. C squared, I'll add 25. Now I have a squared. Knowing a squared, I'm going to take the square root of that. So I'll raise it to the power 1 divided by the root 2. That's my square root, right? 7.68. So if we are rounding to the nearest tenth, that will be 7.7. So A is equal to 7.7. Now, I never did write down what the cosine was. Do you care about that? I probably should put it in. 0.3746, just so you can check against your own work if you didn't catch it off the calculator. Now I'm going to switch over to the law of sines, and I want to know the sine of 68 degrees, and I want to divide it by 7.7. Bring this calculator back up. We'll find the sine of 68, and we will divide it by this number up here, 7.683. Yeah, you want to go out 4 decimal places. Do you really? I guess you don't really have to do that. Okay, so we get a ratio of 0.1207, we'll say, equals 0.1207. So beta, sine of beta, which we do not know, over its opposite side is going to have the same ratio. Law of sines is really a neat one, isn't it? It's actually pretty quick to use too. So I multiply this times 8, and now I know that my sine of b is a 0.96, etc. Of course, what I really want to know is what beta is. So I'm going to take arc sine of this ratio 0.9654. And that will give me the angle, 74.9. So my angle is 74.9 degrees. I add 68 to that, plus 68, and find the difference with 180 to know what gamma is. It's 37.1. We add these all up, we get 180. 37.1 degrees. Very good. Example 18 on this page. I'll switch colors. In this case, beta is the one that we have. So for number 18, we're going to use this formula. We'll find out what b squared is. We're going to So let's pull over our calculator and start to figure this out. We're going to be using this formula, so we're going to take the cosine of beta. The cosine of 14.3, and then we're going to multiply that times a and c, and a -2, let's pull that back, times a, which is 6, times c, which is 26, times a -2. And that gives us a pretty big number. We're not too surprised by that, because cosine of such a small angle is almost 1. Now we're going to add to that a squared and c squared. So plus 36 plus, I'm not going to try to do c squared in my head. So we'll do 26 squared, that'll be my c squared. And we find out that b squared is equal to almost 410. We're going to take the square root of that, raised to the power of 1, divided by the root 2, 20.24. All right. So I get b is equal to 20.24. I'm not going to round it because I'm afraid if I round it, especially when you're dealing with small angles, I might throw my angle measures off too much. Be careful about rounding. So I'm going to do the law of sines now, which will be the sine of 14.3, sine of 14.3 divided by this side, which is 20.24. So my ratio 0.0122. So for law of sines, I've got a law of sines ratio of 0.122. So I know that my sine of 14, oh no, I want to go for alpha. Sine of alpha over its opposite side, 6, will equal this ratio. So clearly the sine of alpha is going to be 6 times that law of sines ratio, so times 6. My sine of alpha is 0.0732. I have the ratio, I want to find out what alpha is. I go to arc sine of that ratio, 0.07322, and I find that alpha is 4.2 degrees. Alpha is 4.2 degrees. So what does that tell me about gamma? Certainly obtuse, isn't it? If I add to 14.2 my beta, 14.3, this was 4.2 plus 14.3, and then I find the difference with 180, I know gamma is 161.5. 161.5 degrees. Okay, that looks pretty good to me. How does that look to you? Now we could be off a little bit if we rounded too much. Watch out for that. If your answer is not looking as close as you think it should, you probably did round things too early in your calculations. We got two more examples we're going to go through. We're going to find, oh, this is interesting. Oh, so we're going to look at the longest side. So which of these is the longest side? This is the longest side. So this tells us, for example 17, for number 17, I'm going to do this one here. I want to be solving for this. So let me put it over here. 2ab cosine gamma. What I did is I added this to both sides, equals a squared plus b squared minus c squared. You see what I did? I subtracted c squared from both sides, and I added this to both sides. So I know that the cosine of gamma is going to equal a squared plus b squared minus c squared divided by positive 2 times a times b. So let's get the calculator out and let the calculator do all the heavy lifting for us. A squared is 49 plus b squared, we'll work with this one down here, oop, plus b squared, which is 81. 81 minus c squared, which is 144. Okay, so there's our numerator. Turned out to be a negative 14. I'm going to divide that by 2. So divide by 2. And then I'm going to divide it by a times b, which would be 63, right? Divide by 63. I get a negative 0.1 forever, right? So this is equal to negative all kinds of ones. All right, if I know what cosine is, I can find out what the angle is. I know it's going to be obtuse because it's negative in the second quadrant. So our cosine of negative 0.11111111. I could go on and on, couldn't I? 96.4 degrees. Here it is. 96.4 degrees. Now I can figure out what the law of sines is. That's going to be the sine of 96.4 degrees over 12. That'll be my ratio that I'm interested in. Let's move this a little more so we can see everything. Sine of and I can use what I've got on my calculator, be a little more accurate. It prevents me rounding prematurely. So the sine of that angle divided by 12 will give me my law of sines ratio. Okay? And if I multiply that by 9, it'll give me the sine of beta. So times 9, give me the sine of beta. And I will say I want to know what that angle would be that has that sine. So I do arc sine of that ratio, 0.74, 355. Yeah, I've gotten a little scared of rounding too soon because I found it can sometimes throw the angle measure off. 48.2, 48.2, and I don't even have to use any trigonometry. I just use my knowledge of geometry to finish it off. I'm going to add 96.4, find the difference with 180, and now I know my alpha is 35.4. 35.4. Now, in the interest of time, I probably won't go ooh. It's so interesting, though. Look at those great big numbers. You know, I might not even use these great big numbers because the angles, if this were 6 and this were 4 and this were 5, the angle measure would be just the same because these would be similar triangles. It would certainly be a lot easier than using 6,000, 4,000, and 5,000. So I'm going to leave that one for you. I'm not going to do it right now, but that's a little hint if you get big numbers like this. See if you can use smaller numbers that have the same ratios to one another. So you can do that one on your own back in class, and we'll also work on your homework problem number 4.